Hey math kids, today we're going to talk about definite integrals involving substitution. And we will just start with these two. Okay, so on this one we're going to say that our u is x squared minus 1, and then our u prime, or du, yeah, let's just call it du, I think that's better, it's 2x dx. Okay, and so if we start simplifying this, we're going to say u is on the bottom. And then we don't have a 2x dx, but we could put a 2 in and then also put a 1/2 to cancel that 2. So all of this is going to go to du. And so we have a 1 over u and a 1/2. Now, these are with respect to x. We need to change our limits of integration with respect to u. And so we're just going to plug these into this thing. So if we plug in a 2 here, we get 2 squared minus 1. That's 4 minus 1. So that bottom one's going to be a 3. And then if we plug in a 3, we're going to get 3 squared minus 1, which is 9 minus 1. So we put an 8 for those limits of integration. Okay. Now, if we take the antiderivative of this, we get natural log of the absolute value of u. And then we have a 1/2 on the outside of that. Okay. Now we plug in those limits of integration. Natural log of 8 minus natural log of 3. And since those are positive values, we can drop the absolute value signs. And then from our rules, our log rules, we know that that's 8/3. Subtraction becomes division. All right. Okay, now in this one, we're going to let our u equal this, which means our du is going to be 2x. Okay, now when I start plugging stuff in, I'm going to get a u on the bottom, u cubed actually, and then this is 2x dx, so we have a 6x, so we're going to think of the 6 like 2 times 3x, and so we use up the 2, use up the x, use up the dx, turn that into a du, and the 3 can hang out on the outside. Now, we need to change the limits of integration, so we plug them in here. Plug in a 0, that's just going to give us a 1. Plug in a 1, that's going to give us a 2. Now, I'm going to think of this as u to the negative 3. We raise it by 1, divide by the new exponent. Okay. That's going to be evaluated from 1 to 2. And then we do a 3 out here. Okay. So I'm going to rewrite this just a little bit. I'm going to say 3 times negative 1 over 2 times u squared before I plug it in. Okay. So now I plug in the 2. Subtract that from when I plug in the 1. 2 squared times 2, that's just 2 cubed, so that's negative 1/8. And this one is going to be, so negative negative would be a positive, and this is just going to be 2. The 2, if I multiply that by 4 over 4, I get negative 1 over 8 plus 4 over 8 3 over 8. And I have that 3 on the outside, so that gives me 9 over 8. Okay, this next one, we're going from pi sixth to pi halves, and we have the square root of sine x cosine x dx. Okay, so I'm going to choose the u to be sine x, which means if we take the derivative of that, we're going to get cosine x dx. Okay, so we put our u under the square root. All of this becomes du, and then we just need to change our limits of integration. So if we plug in, so if we do sine of pi sixth, that gives us 1/2. And then if we do sine of pi halves, that gives us a 1. So you can use your unit circle or possibly a calculator if that's easier. Okay, so we're going to go from 1/2 to 1. I'm going to think of this as u to the 1/2. So I raise that by 1, divide, and evaluate that from 1 to 1/2. I'm going to pull out the constant just to make it a little bit easier. Then I get this. Okay. So we're going to still have our 2/3 on the outside. That just goes to a 1. And then to evaluate that, it's going to be 1/2 cubed under a square root. So cube the top, cube the bottom, that's 1/8. 1/8 under a square root. Okay, we still have a 1. Square root of 1 is just going to be 1, and then 2 square root of 2. So to get a common denominator, we can do 2 square root of 2 over 2 square root of 2. So we have 2 square root of 2 minus 1 over 2 square root of 2. I mean, I don't know how far we want to really take this, but we can distribute the 2 to the top, so it's 4 square root of 2 minus 2 over 6 square root of 2. Really, any of these answers are fine. So we'll just move on from there. Okay, now we have -4 to 6 x plus 4 dx. So our u is going to be x plus 4. Our du is going to be 1 dx. So when we do this, we replace the u under the square root. We don't have an x, but our 1 dx becomes du. So the way we find the x is we use this equation and just solve for x. So I'm going to replace x with u minus 4. And let's replace the limits of integration as well. And the limits of integration are, if we plug in a -4 here, we're going to end up with 0. If we plug in a 6 here, we're going to end up with a 10. And I'm going to think of this as u to the 1/2 and distribute. So if we add those exponents, we get u to the 3/2 minus 4 u to the 1/2. So I just distributed that there, 0 to 10 du. Okay, now we take the antiderivative of each piece. Let's simplify that before we do anything. Okay, so 2/5 u to the 5/2 minus 8/3 u to the 3/2. Now, if we plug in 10, we're going to get minus, if we plug in a 0 here, it goes to 0, minus 0, minus 0. And so we don't need any of this part. And they want us to find the exact answer, so they don't want us to use a calculator. So if we think of 10 being raised to the 5 halves, that's 10 to the 5th under a square root. And so that's 10, 10, 10, 10, 10. So we can pull out 2 and 2. So we have 2/5. We pull out a 10, pull out another 10, and then we have to leave a 10 under a square root. So that's just for that part. Minus sign. Now 10 to the 10 cubed under a square root. So that's 10, 10, 10. Pair of 10s, we can pull that out. So we have our 8/3. Pull out the 10, and then we have to leave a square root of 10. Alright, multiply all these together, we get 200 over 5 square root of 10. Then we get minus 80/3 square root of 10. So we can factor out square root of 10. 200 divided by 5 is going to be 40 minus 80/3. And so if we multiply that by 3, we get 1/23 minus 80/3 square root of 10. Subtract those, we get 40/3 square root of 10. And I think that's our answer, 40/3 square root of 10. Yep. If you have additional questions, please come to Math Lab. Until then, calculator.